Hello all, and welcome to your last week in chapters 5 and 6 talking about geometry. So make sure that you are thinking a little bit ahead, that you have a test at the end of next week. So right before winter break, in terms of any missing assignments or anything like that that you'd love to be caught up on before we actually go into our break. All right, let's get started with notes. So find this page, and the first thing we're going to do is fix this little typo. 6.6, it says number 1 through 11 off. That is odd. That's your problem set. I know probably a lot of you could have figured that out on your own, but just wanted to make sure that I did address it. Now, we're going to find the volumes today of prisms and cylinders. So the first thing that we want to do is make sure that we're all on the same page about what a prism is. Now, a prism is a three-dimensional figure, like what we see here, with parallel bases, meaning that the shapes here and then back here would not intersect if they continued. The base in this case would be a circle, and there's a parallel one back here, and rectangular sides. So like this is a rectangle, this is a rectangle, the bottom here would be a rectangle. That's what a prism is. Now, most of you are going to be familiar with the volume of a rectangular prism. Now, a rectangular prism would be something like a box. So an example of a rectangular prism. And the reason that I'm separating this one a little bit is that in this case, it doesn't necessarily have an easily identified base. Any of these sides could be bases since they are all rectangular. So we just say that we have a length, a width, and a height. And the volume is equal to the product. So length times width times height. Now, when it comes to a volume of a cylinder is a shape like what we see here, which has a circle on one end, sort of like a pipe or a tube. This, we are going to use the volume is just like how length times width here. That's the area of a rectangle. A cylinder has an area of a circle as its first thing. If you remember from last week, the area of a circle is pi r squared, and then times the height. What's important here is that the height is not necessarily how up and down tall it is. If we look at this picture here, the height is the distance. I don't know why it's not gone. The height is the distance between the circles. Because the circles, remember, circle is the base here. So in this case, if I'm looking at the picture number 2, we'll get to its area in a second. Its height is 15, because that's the distance between this front circle and this circle in the back. And that's going to be true for any generic prism. So the volume of any prism is going to be equal to big B is how we usually write this. And this is the area of the base. And you'll use whatever formula is appropriate. If it's a circle like a cylinder, you'll notice we used pi r squared. When it was a rectangle, we used length times width. If it was a triangle, we'd use 1/2 base times height. So whatever shape it is, you just use the correct formula and then times the height, which again is the distance between the bases. It's not what's on the up and down direction, but it's the distance between the shapes that aren't rectangles. The sides that are not rectangles. Now, so for example, if I'm looking at number 1 here, it says find the volume of the prism. Now, the first thing I always like to do when that's the problem is I'm going to identify what the base is. Well, there's only one non-rectangular side I see, which is this side facing us here. So therefore, that is our base, which in this case is a trapezoid. Now, that means that we're going to use the formula 1/2 base 1 plus base 2 times height. If I'm looking at just that trapezoid, just the green shape, that means that our base, if I'm looking here, 8 is this distance across here, so that's our first. Our second, this distance here, 14. And then the height, whoop, not plus, times the height of the trapezoid is 4. So you'll notice here this difference. This is the height of the trapezoid. If I look at 10, this is the height of the prism, since it's the distance between the two. It's hard when sometimes words are being used in several contexts, so that's why I always recommend that what you do, what I just did here, is you find the area of the base first and then deal with the non-base part. So when we think about our formula, that's going to be the tricky part, and then you just figure out what the other number you multiply it by is. So in this case, I'm going to say the volume is 1/2 times 8 plus 14 times 4 for the trapezoid base times 10 for the prism. So this is big B, and then that's the height of the prism. From there, we just want to follow our order of operations. 1/2, and then 8 plus 14 is 22, times 4 times 10, which is 40, which is 440 centimeters cubed for the volume unit. Now, so that's how you find with the trapezoid. If we're looking at a cylinder, as we see here, it also, you'll notice here, and this is something I talked about in last week, leave in terms of pi. That means that I should see this pi symbol in my final answer. So if I have pi r squared times h, looking at this picture, 4 doesn't represent r. 4 is equal to the diameter, which means that our radius is 2 meters. So when I plug in here, that gives us pi times 2 squared times 15 for the height. Again, following our order of operations, pi times 4 times 15, which gives us 60 pi, and I'm not going to multiply by anything there. I'm going to leave it in terms of pi. 1, because it says so. 2, because it is more accurate and easier. And then our unit is meters, and its volume, so cubed. This is sort of the way we're used to finding volumes. You might be also asked this slightly more complicated question. Number 3, the volume of a cylinder is 28 pi meters cubed. If the length of its radius is 2 meters, find its height. So in this case, you don't have a picture, but you're still dealing with the volume of a cylinder. So what that tells us is that we are going to have to use the equation V equals pi r squared h. However, in this case, we are not trying to find the volume. We know that the volume is equal to 28 pi. Pi stays the same. We know that the radius is 2, since it's given to us right here. We don't know the height. Now, the nice thing is that we have things left in terms of pi. So the first thing I'm going to do on both sides of this is divide by pi. And we only have one variable here. So that's how we know we can solve. We can only solve for one variable at a time. So now we get 28 is equal to 2 squared times h. That means 28 is equal to 4h, meaning that's 7, and then you'll notice the unit is meters cubed and meters. So 7 meters is the height. This is definitely one of those times that I recommend having your formulas out and ready as you're working on your homework. You'll, as always, be able to use your formulas and your notes and everything on your quiz and on your test next week, but it's nice to sort of start thinking about getting them in a nice organized place so you're not flipping constantly back and forth through all your pages. If you have questions, make sure you're nominating anything you're stuck on in the form attached. Make sure that you also can send me emails look at comments that I leave you, as well as set up a Zoom call if you're